Hey, I've got an idea. Let's get out in the great outdoors. The great muddy outdoors. Look at this. It didn't take long with this weather today getting up over 40 degrees Fahrenheit. Look at this mud down here. What a muddy mess. Oh, what a chocolate mess. Look at these puddles. Check it out. There's a downy woodpecker going up that tree. The downy woodpecker will actually eat our birdseed sometimes. That's so cool to see that. It's a downy woodpecker. Water. That's right. Snow is one form of solid water. Ice is another one. And as we walk towards the pond, which has been covered with ice, I wonder what we'll find. The temperature today has gotten over 40 degrees Fahrenheit. I know. Whoa! Over 40 degrees Fahrenheit. So I wonder what has happened to the ice on top of the pond. What do you think before we get there? I'm walking on this skinny little deer trail and we'll see. Wow, look at there. Wow, check out the pond. It's not white and snowy and it's not shiny and hard ice. Look at that gray. Look at the tracks on the pond. What do you think it's like if we try to walk on that? Shall we find out? I know the ice is still safe. There's a lot of ice. But this is slush. Look at the slush on this. Watch, 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 watch. Wow. That's pretty cool. Yeah, there's a layer. There's a layer of slush. You know what a slushy is. Look, there's a layer of that on top of the thick ice on the pond. So it's melting. It's taking its time, but it's melting. When solids get warmer, they melt and turn into a liquid, most of them. And that's what's happening to the ice that's on the pond. It's still safe. There's still a thick layer of ice underneath me. But the slush is amazing. Look at this. Wow. So today you can tell it's getting warmer because you can look at the pond and you see that slush. That slush tells you that the ice and snow is melting. It melts because it gets warmer. And then something else is happening. We know it's getting warmer, so the ice and snow start to melt. Melting is when a solid turns to a liquid. And this time we're talking about water, H2O. But check this out. As the water, today especially because it's not raining, as the water sits there and the sun shines on it and it warms up, it's starting to vaporize. So there won't be quite as much flooding this year if this continues because the sun and the breeze will help to evaporate or vaporize that liquid and turn it into a gas. Yeah, it's turning into an invisible gas right now as we speak. Hey, look, there's a hawk flying in the distance. Awesome. Can you see it? That is so cool right over the pond. Hey, friends, listen. Now, tonight, as it gets colder tonight, things are going to start to freeze. The liquid will turn back into a solid and it will freeze. And friends, all of these changes we're talking about, melting, freezing, vaporizing, even condensing or condensation, it's still H2O. The particles that make this have not changed. They're still hydrogen and oxygen chemically combined. That's right, the compound water or H2O. It's a compound because it's two or more elements that are chemically bonded, and it's hard to get them back. By themselves, hydrogen and oxygen by themselves are gases. As an element, hydrogen is a gas that's explosive. Oxygen is a gas that we need to breathe. So these two elements, hydrogen and oxygen, chemically combine to form this compound called H2O. It's all pretty amazing, isn't it? And all of these changes that you're seeing right now before you, all of these changes in states of matter, they're all physical changes. Just physical, not chemical. We'll get into that again. Amazing. Nature's so beautiful. So glad you're here with me today. So water plus snow equals slushy. Not the kind of slushy you want to drink, But this is slush. It's a combination of snow and liquid water. Hey, look at the color change. You know, with physical changes, there are often color changes like this. The snow is very white, and the slush and the water is a different color. So there are some color changes involved with physical changes. Look at that slush. Slushy! Slush. Hey, I just want to be clear, just so you know, that even though you see these big changes behind me, there's nothing new being made here in the pond. As the snow and ice melts, it's still a physical change. Nothing new is being made. The particles are still H2O. They're still water particles. Pretty cool. Now let's take a look at chemical changes again. Hey friends, I think you already know, in a chemical change, something new is formed. And the particles do change, unlike a physical change. Now, I think I already showed you, lighting a match kind of shows us that. You can see that the match changes a lot after it burns. Look, now the match looks like this. What about this? What if I take this wonderful stuff called birch bark? I got this off a dead tree up north. What if I burn that birch bark? Will it still look white and cream colored like this? Let's take a look and look at the change that happens when this birch bark changes chemically. So I'm going to light that on fire and see what it looks like. I'm going to carefully take this match and I'm going to see if I can block the wind a little bit. Now I've lit this piece of birch bark on fire. Look at the smoke coming from it. There are oils in birch bark. Look what's happening. Look at the change in color. Wow, look at that smoke. This is birch bark. And as the birch bark is burning, it's changing chemically. The particles that make the birch bark are actually changing into something different and something new. Whoa, look at that. That's what's left over. That does not look like the birch bark. Now it's black ash. Friends, in a chemical change, the particles do change and something new is formed. That's very different than the melting of snow and ice on that pond, isn't it? Chemical changes, different than physical changes. Peace out. Friends, these changes that we see in states of matter, going from a solid to a liquid to a gas and back again, these are all triggered by temperature. Take a look at that. The temperature right now, it's even later in the afternoon and it's over 40 degrees Fahrenheit. So we're looking at how to read thermometers and realizing that temperature makes a big difference in the changing states of matter. It's only a physical change, but it's triggered by temperature. Amazing. Temperature.